My name is Chris Hostetter, or Haas, as a lot of people know me. We're going to go ahead and get started, because it's 9:15, and that's when they told me I should get started. We're here today to talk about boosting biasing, which is really just a catchy phrase for what I like to call using domain knowledge and using your user knowledge. The term user analytics appeared in the description of the session. I just want a quick caveat for people. I'm not going to spend a lot of time or any time talking about how to gather user analytics, things like that. I'm sure there's some really good Hadoop talks going on somewhere, or you can talk to Isabel about Berlin buzzwords. This is more about taking knowledge you have, however you got it, and what you can do with it to improve your search experience. So our agenda for today: a quick primer on some concepts, just to make sure everybody's on the same page. Then talk a little bit about using your domain knowledge, how you can take advantage of it, and then using user analytics, how you can take advantage of it. So show of hands, who here is any of this information new to anybody? Is there anybody who has never used Solr before? Fuck you. Okay, so the nutshell: Solr has some configuration files. You use them to tell Solr what kinds of things you are searching and how you want to search them. This slide is really the key one, where I want to make sure is top line is a very simple Solr query. Second line is a slightly more interesting Solr query using a different query parser. And then this last line, or this last block, I should say, this is kind of an interesting example. I need an actual show of hands, not a fake show of hands. Is there anyone who's just completely foreign to this syntax, particularly this example here where I've got curly braces? Should I explain? Okay, all right. So, but you guys are familiar with like the first two examples, right? Is there anybody who the first example is just totally foreign to you? Okay, so what we see in this third example, building off of the previous ones, is a concept in Solr called local params and nested query parsers, or sorry, embedded query parsers. What we're saying here is, this is our main query, and instead of it being a simple query string where the def type determines how it's parsed, we use this local param syntax, a curly brace, to specify which parser we're going to use. And then there can be embedded parameters that tell that parser how to behave, including the magic V property, which is basically what the string should have been, right? What you want to parse. And these can then refer to variables. So here we're saying take the boost parser. The B parameter should get the variable B, which comes from here. The def type parameter is going to be dismax, and the body of what we're going to have dismax parse comes from the QQ parameter. Okay? So this is the local param nested query parser syntax that Solr supports, which can be really powerful. What this is saying is, go find some other completely arbitrarily named parameter, QQ, parse that using the dismax parser, take the query you get out of that, and wrap it in whatever the boost parser gets you. What the boost parser gets you, we'll talk about in a minute, but it has something to do with this B parameter and this bizarre function down here. But I want to make sure everybody knows about that local param syntax, because we're going to talk about that a lot. All right? Now, this is the Solr primer. Information retrieval. TF-IDF. This is Thilo Fromm and Isabel Drost Fromm, very lovely people. If you tell them about your data, they will understand it. They will give you good advice. They will be able to make sense of your business rules. But unfortunately, they are not in your computer. This is the TF-IDF that is in your computer. This TF-IDF is the basic formula that Lucene uses for scoring text. There are other formulas that Lucene can use, especially now in Lucene 4.0. You can customize this a little bit. But the key things I want you to understand, don't worry about the math so much, but if you do look at the math, these are really the big pieces of what's going on in that math. Okay? How many terms you match is important. How many text terms in your user input you match is important. How many occurrences of those terms are in each document is important. How common those terms are in your entire document set, that's important. That's the document frequency, which we take the inverse of. And then there's this notion of length normalization. How long is the field, right? These are all the things that classical TF-IDF cares about when scoring your documents. But you'll notice there's nothing about your domain in there. There's no knowledge of what you're searching. There's only knowledge of text rules, right? Give me an example, somebody, of what you search. Just shout it out. What are you searching? Any user of Solr right now, what do you search? Products. Okay. So, sorry, what was your name? Yeah, who said yelled products? I thought that was you. Yeah, what's your name? Jan. Okay, so Jan searches products. He doesn't actually search physical products. He searches text and data about his products, right? The computer does not have all of his T-shirts or laptops in it. It has textual descriptions and numeric descriptions of those. Nothing in here knows about products. Nothing in here knows about the sales rank of a product, the price of a product, the popularity of a product, the color of the product. All it knows is words. So it's not going to be able to apply the domain knowledge that you might already have about your own data to factor that in. It only knows about text. It only knows about keyword frequency, keyword commonality, things like that. That's what we mean when we talk about domain knowledge. So when I tell you you need to think about your domain knowledge when you're designing your Solr schema, and you need to think about domain knowledge when you're designing your queries, I'm talking about you need to think about what is fundamental in my data. Not just that my data has a description and my data has a title, and those are the things I want to search. You need to think about what is important in my data. In most cases, I've yet to find a case where this isn't true, except for really, really classical, like, I am searching text. That's all I'm searching. In the abstract, I am searching web pages and text. There's almost always properties that you can say, yeah, in my domain, this property over here, this field, based on some ordering or some implicit relationship, this tells me in the absolute sense, independent of any queries, some documents are better than others, just inherently. Some are more interesting. So some common examples of domain knowledge, products being the one that a lot of people are familiar with, and I have a lot of familiarity with it. You get into a lot of things like cheaper. People tend to like the products that are more affordable to them. On the other hand, more expensive products can also be the more interesting ones, so you have to kind of decide. If you saw a talk yesterday from, Adrian, I think his name is, who worked at Gilt, which is like a premier shopping site, he would probably tell you the more expensive products are the more interesting ones. For his user base, the ones that cost millions of dollars, those are the ones that are inherently more interesting to his users. Newer or more recent, this applies to products. It also really heavily applies to news. If you're searching like a news-based site or a social media type situation, how recently that content was created can be really important to your users. Popularity. Popularity can either be in-application popularity. If your application is a website, how popular is the information that you're returning in search results? How many clicks does it get? But it could also have real-world ramifications. How popular is this physical thing in the abstract based on metrics that I've gathered from external sources? User ratings. User ratings, in my opinion, are really distinct from popularity. User ratings are the user's expressed opinion as opposed to the observed opinion. There are a lot of people who will tell you, who here has ever heard of Honey Boo Boo? Okay, one person watches E. Honey Boo Boo is an American TV personality that I think 90% of Americans who have heard of Honey Boo Boo would rate her 1 out of 5 or would ask, can I rate 0 out of 5? But that doesn't stop Honey Boo Boo from getting a ridiculous amount of TV traffic and from getting like 4 spin-off television shows and absurd things like that. That's what I mean by popularity versus user opinion or user ratings. And then these are really sort of primitive concepts, but you can always make interesting combinations. I've worked with people who sort of defined the value of something as how highly is it rated versus how much does it cost. And then they wanted to sort of weight their search relevancy based on that. You know, I don't want to necessarily promote the cheaper products because the cheaper products are crap in a lot of cases. But if it's cheap and everybody seems to like it, that should go, you know, I should boost that. I should give that more visibility in my website or in my search rankings. Staying power is another really interesting one, particularly in like a news or a media space or web blogs, things like that. The fact that, you know, you have a story on the front page of your news website and it's getting tons of traffic should not be surprising to you. What should be surprising to you is when you have a 3-week or a 3-month-old story and it's still getting relatively consistent traffic. That's got a lot of staying power. That's an interesting article. That's something you should pay attention to. Okay? So far, you notice I haven't really talked a lot about search. I'm just talking about understanding your data and understanding, what you can do with your data, what is important about your data, because you can feed that back in later. Some more subtle examples of this. Novelty factor is something that people don't really think about. If you imagine, a Yelp type site, the thing that everybody rates a 5, that's a pretty popular place. The thing that everybody rates a 1, that's pretty terrible. But the interesting places might be the ones where no one can agree, where you have an even distribution of ratings. Just as many people rated a 5 as a 4, as a 3, as a 2, as a 1. That might be, for a lot of people, the more interesting, the people who want to try something controversial might be more interested in that. Profit margin really comes in handy for a lot of business users to be able to tell them, let's promote the things that are going to make us the most money once we sell it. Scarcity, Adrian's guilt talk really brought this home. People really like the idea that there's only 2 left. It's like, oh, wait a minute, I should act now. If you're a commerce site, maybe you really want to feature it, especially you have to tell people, you don't want to hide it from them if there's only 2 left. But if you're going to tell people quantity remaining, maybe you want to boost those a little higher in visibility overall in your application. These last 2 are a little more interesting. Manual ranking, like I say, is really just sort of an external factor. It's something that you have curated information about your content. The New York Times top bestseller list is one example. Regardless of its sales rank, a bookstore might say, we really need to be more featuring and more promoting of the New York Times top seller list. Popularity by association, and if we continue with the book example, this might be something like categorization. This might be saying, at our store, mysteries tend to sell better than cookbooks. So when a new mystery comes in, even if we have no sales rank for it, even if we have no popularity information, even if we have no idea how good this book is going to be, we can generally assume that since mysteries sell better, maybe we should feature mysteries more overall in our application or in our website. But it can also be more subtle, and that's where this example here comes in. It can be time-based. Sweaters, even if it's a brand new sweater that you just added to your store, you have no information about how popular it is or its sales ranking or anything like that. If it's November, that sweater is probably going to do better than a swimsuit. So that's where those sort of associated properties can fit into your domain. So how do you take advantage of that information? Once you have it, what can you do with it in your search results or in your website or in your application to take advantage of it? These are sledgehammer approaches. These are things I don't recommend, but at one point in my career I have been asked to do or told to do or did on my own because I didn't know any better. So the first thing you can do is say, I'm going to just ignore score. I'm going to say that I'm a news site, and therefore the publication date is the only thing that matters in how I'm going to return results to my users when they search for articles. For a lot of news sites, this works fine. The example of where this is terrible, that actually specifically is why I convinced someone that this was terrible, was when AOL bought Time Warner. A lot of people in this room are too young to remember this, but AOL was once a really important company. So important that they were able to buy Time Warner, which just blew everybody's freaking mind. No one could understand how this little internet company got so big that they bought out Time Warner. But the result was tons and tons of news about AOL Time Warner, lots of people writing big, long exposés about AOL Time Warner and the buyout and all that. And it was huge news that, was front page kind of stuff for weeks and weeks and weeks. The problem was, if you were a technology news website, you would have your big in-depth articles about AOL Time Warner. But then you would also have hundreds and hundreds of little articles about how the market had done that day, little accounts of various things. But because this was such a big story, it was ancillarily mentioned in every other article, right? So a routine one-paragraph article on the ups and downs in the market would mention at the end that something had been affected by the AOL Time Warner merger. And if you were sorting by date, that meant that if you came along on a Friday and you searched for AOL Time Warner because you had just heard this has happened on Monday, you might have to go through 10 pages of bullshit articles that just very peripherally mentioned AOL Time Warner before you would actually find that huge 20-page expose on how this all happened, because you were ignoring your score and you were only sorting on date. This is why we don't do this anymore. Likewise, you can say things like, recency is all that matters. So I'm going to filter by date. I only want to show things if they've come up in the last 6 months. And if you're really smart about it, you say, but if I don't find anything, then I'll retry. This works, but if you were in Mikhail's talk yesterday, yeah, I'm putting it on you now. I gave an example yesterday where this can definitely burn you. PowerBook was an example when I was working on a tech site. PowerBooks, I don't know how often they come out now or if ever, but they used to come out with like one new PowerBook every year. So the result would be you'd come along one day and you'd search for PowerBooks and you'd get a couple hundred results of accessories and PowerBooks and all that kind of stuff. You know, everything that might relate to PowerBooks because there hadn't been a reviewed PowerBook released in the last 6 months. So you'd find the accessories. Anybody who mentioned PowerBook, you'd find those sorted by score. And then the day a new PowerBook would come out, it would get reviewed, and this logic would kick in. And now suddenly you'd only see 4 results, and they'd be the 4 PowerBooks that were just released yesterday. And so people who were like, great, but what happened to all the PowerBook accessories that I was shopping for and doing research on last week, and I decided I want to buy today? You know, I was like debating whether I wanted that new mouse. And now that the new PowerBooks come out, I definitely want to buy that new mouse, and you're not even offering it to me anymore. So again, another sledgehammer you can use. I don't recommend it. Magic keyword stuffing. I'm not even going to go into this example because it's just kind of painful to explain, but I will show you the dark ages of domain knowledge. Before Solr existed, and I was using another product, shall we say, there was no concept of numeric fields. There was no concept of boosting. There was no concept of relevancy tuning, tweaking. If you wanted to say that the title was 3 times as important as the manufacturer, or the product name was 3 times more as important, you would put the name in 4 or 3 times, right? For those of you who don't know, by the way, another historic lesson for those of you young ones, Palm was this really awesome company that was kind of like the iPhone back in the 90s. The Palm 3 was like the pinnacle of evolution back in 98. And it was made by a company called Palm Inc. I know, creative naming, right? So this was the data we might index for the Palm 3. We might say its name is 4 times as important as anything else, so we're going to put the name in 4 times. And then the manufacturer's name is 2 times as important. In cases like this, where the manufacturer's name and the product name overlapped, that meant this guy did really well when you search for Palm, which is why a lot of manufacturers did that. But if we wanted to have price filtering, you know, we didn't have numeric fields, so we would actually encode these special keywords with the ranges of prices we wanted to match. So then later on the website, when someone clicked a link, like, yeah, I want $500 to $700 products, we could search for that. If we ever wanted to change those links, it meant stopping the world and rebuilding the index, and everybody took a vacation for 3 weeks. But likewise, ratings. If our editors reviewed a product and said, this gets a 7 out of 10, well, then we would go index all the ratings that it had earned. So this one, it cropped off there, but this one was a 7 out of 10, so we indexed all the ratings, 1 through 7, but not 8, 9, and 10 for this product. And likewise, popularity. This was, Palm 3 was the bee's knees, man. It was in the top 100 products on the whole site. It ranked, like 89. So we would round that to 90. And then at query time, if the user typed in the word Palm, okay, that's mandatory. Here's all the other shit we had to do to tweak our relevancy. We had to say, search for all of the rating keywords 1 to 10, and this guy's going to match 7 of them, so that's pretty good. But if somebody actually got a 10 rating, he would match even more, so his score would bump up. Popularity was a little harder because the lower number was better. So there we would say, all right, search for popularity 10 times, popularity 20 9 times, popularity 30, et cetera, et cetera. This query was huge until you get to popularity 100. And this guy, because he was around the 90th percentile, he would score pretty good on this, relatively. Yeah. Now that you've been scarred by that image, I'd just like to take a moment, deep breath, look at something pretty, something orderly, something elegant, something mathematical and logical. Okay, I feel much better now. So in the non-dark ages, in the modern era of search and relevancy, what can you do to take advantage of your domain knowledge? The first thing you can do that I just want to make sure everybody thinks about is you can work with the algorithm, right? I put a lot of importance on functions and boosts and taking advantage of your numerical data. But before you ever even get to that point, you should think about the algorithm you're actually using. So just as a low level, or not as a low level, I'm sorry, as a high level, as a very simple thing you can do without a lot of expertise about Solr, you can take advantage of the existing query parsers. You can take advantage of things like edismax or dismax, work with them. Instead of trying to custom create some query where you're really creative about how you write the query structure, use things like edismax, which let you say these fields are more important. For a lot of people, that gets them 90% of the way there. Being able to say things like title text is more important than body text. That's huge for a lot of people who haven't thought about it. It's definitely the first step. The second thing is give TF-IDF useful hints. Without a lot of customization in the schema, you can do things like omit term frequencies and positions. If you don't need phrase queries, you don't really need positions. If you have really short text, frequently TF doesn't matter for you. When you're doing things like product titles, if someone searches for iPhone, you don't really care if the word iPhone appears in the product name twice, because odds are it won't, and odds are if it does, it's some keyword spammer who's fucking with you, and they've said, these are iPhone headphones for iPhone 5 and iPhone 4. You know, they're like deliberately trying to game the system. So disabling TF for a field like that might actually improve your relevancy. Likewise, omitting norms. If you have a text field that is prone to keyword stuffing. You know, you've got third-party merchants providing you product descriptions. You might want to match on that field, but you might not want to reward them for having really crappy short product descriptions. What usually happens is the really good products have really long descriptions that are very detailed and well thought out and don't contain keyword stuffing, and then the really crappy products have like 2 words. So length normalization there might actually hurt you. So it's not a panacea. It's not something everyone should just immediately do because Haas told them to, but it's something to think about, how you can work with those existing tools. And then the more complicated sort of approach is to actually customize your similarity. I mentioned that TF-IDF is sort of the default, and as of Lucene 4, there's others. There's BM25 and language models and divergence from randomness and a bunch of others that I don't fully understand, but in your domain, they might make more sense than TF-IDF. They're still all working with text. None of them are going to know that you're dealing with products or news or blogs or whatever your actual domain is, but they and how they do scoring may be a better model for the text data you have. And you might be able to customize them. Sweet spot similarity is an example of a subclass of the default similarity, which allows you to tune and tweak and say, you know, in normal TF-IDF, the longer something is, the more it's penalized. In sweet spot similarity, you can say, up to a certain length, it's all good. It's all the same. Only after that length should it start getting penalized. Likewise, for the TF function, you can customize it and say, terms, you know, I expect there to be maybe 1 or 2 of this occurrences. Anywhere around there, treat it equivalently. Above that, that's bizarre. Stop. You know, like you can actually make the more terms it matches, penalize it, as opposed to the more terms it matches, it does better. Things to think about when you're sort of thinking about your domain is working with the algorithm. The other thing you can do is augment the algorithm, all right? This is where our first example comes in, the idea of boost functions and boost queries. You can imagine saying, this is my TF-IDF score. This is what I get just from the text of my document. What I really want my final score to be is I want it to be that score multiplied by my domain knowledge. So in a product example, I have user ratings. I have how many clicks it's recently got, which might be 0. User ratings maybe is always 1 to 5 or something, or editor's ratings, whatever rating. Maybe it's always a valid positive number. Recent clicks, I don't know, that might be 0, but if it's there, the more clicks, the better, in my opinion. Price, I'm not guilt. My users like cheapness, so the lower the price, the better. So I'm going to divide by the price. But again, that's always a positive, non-zero number. And then something like category ranking. This might be that popularity, or not popularity, I'm sorry, quality by association. I might have a list of all the categories on my site, and I might say, you know, mysteries is the #1 category on my site. How-to books is the #2 category on my site. So the higher the category ranking, you know, the 27th most popular category on my site is not as good as the first most popular category on my site. So again, I'm dividing by that. The recent clicks, like I say, it's the only one of my magical fictitious properties here that might be 0. So I'm going to do this map function where I say, normally I use the recent clicks, but if recent clicks is between 0 and 0, make it 1. Right? This is a special function that Solr has, because Solr has lots of functions to help me with this. this is the equation I want, and this is how I express it. I say my query is a boosted function specified in the b parameter. The boosted function will be multiplied by however my main query is parsed. Here I'm saying it's parsed using dismax, and it comes from this other parameter. So all of the normal things you think about dismax, about field boosting and all that, you could go express there. If you wanted it to be the Lucene parser, you could do that. If you wanted it to be your own custom parser that knows about weird text rules and has weird field boosts and all that, you could do it. This guy will wrap anything you want. Okay, he'll wrap anything you want, and he'll multiply the score you get by your other function. And here I just have some, just for completeness to explain it, this is that map function I mentioned to you. Prod is just the product of multiple things. Div is the division. I'm dividing two things. So here I am saying I want to divide the good by the bad. The good comes from this parameter. The bad comes from this parameter. This is a simple example of saying I know some stuff about my domain. I know about user ratings. I know about how many clicks it gets. I know its price. I know its category ranking. I want to factor those in. I could apply some exponents to all these. I could say I want the rating to be really important, so I'm going to take it to I'm going to square it. I could say that cat rank isn't that important, so I'm going to put it to the power of 0.2 or something. Whatever math equation you can think of for expressing the overall importance of a document, independent of the query the user executed, right? Independent of the query, regardless of whether they search for Palm 5 or Harry Potter or whatever they searched for, TF-IDF will worry about the text. What you want to worry about is, I know what's more popular in my data overall. I know what I want to promote. I know what, in the abstract, users are more interested in. And this is how you can take advantage of that. Before I move on, are there any completely glazed over eye questions? I mean, we'll have more time for broader questions later, but is anybody just completely confused by any of this? All right. Does anybody feel like this is a waste of their time so far and they're like, no shit, Sherlock? Because I can get deeper if you want. All right. So, I'm sorry, I'm getting distracted from my own presentation. So these boost functions that I talk about, these take advantage of your data. In all of these cases, when I said you've got these properties, I'm assuming they're somewhere in your index. I'm assuming these are numeric fields. But there are other things you can take advantage of, even if you don't want to do that. One of them is the external file field. Who here is totally familiar with external file field and knows exactly what it is, and I don't need to talk about it? 3 of you are lying. Not the 3 who raised their hands, by the way. OK, so external file field is a way of saying, I have some data I know about my documents, but that data, I don't want to encode it in my index. I don't want to have to re-index my data every time that information changes. I want it to live in an external file, which will be loaded by Solr at runtime. It will be reloaded every time I open a new searcher or do a commit. Basically, anytime I change my index, reload this from this file. But it allows you to express some data in a nice and easy way that you can then use in functions, but you don't have to completely re-index all of your documents to get it. A really common example that people have used for external file field is things like popularity. You have an index of millions and millions of books, for example, that you sell, and every night your data warehousing process runs and tells you how popular those books are based on a complicated series of analysis of user clicks and whatnot. You don't want to go re-index and rebuild your entire index of 100 million products or 100 million books just because you have new popularity data and somebody that was popularity 27 yesterday is now popularity 34. It's not worth it, right? But what you can do is express all of that in a simple mapping file where you map some field, like the unique ID of your documents, to their numeric value. And then you can use it. So just like in any of these functions here, you could say, now I'm going to pull the ratings out of my rating field, which happens to be an external file field. I'm going to pull my price from an external field, which happens to be my price field. Even the category rank, which doesn't have to be per individual document, right? You could have hundreds of millions of books, but only 50 categories. So your category ranking field that says, what category is this book in, and how popular is that category, he could come from an external field, and instead of mapping to the unique key for your book or for your document, he could map to some other field, right? So I could build my index and say the book Harry Potter is in the category Children's Mysteries, and then I might have a couple 100,000 other books that are in the category Children's Mysteries. This text file that this text file that describes how popular each of my categories are just needs to list the categories and their popularity. And the external file field will take care of making sure that every product or every document in your index gets that value so it can be used in those functions. And then, the caveat being, there's also an easy way to say what the default should be if nobody has a mapping, right? So this could also be used for things like New York Times bestseller ranking. There's only like 100 books in the New York Times bestseller ranking. You don't need to list all 100 million books that you sell and give them a 0. Doesn't have to happen. The last example I want to give of how Solr lets you apply your domain knowledge is something called the QueryElevation Component. This is really a scalpel. It doesn't help in every situation. What this really helps with is very fine-grained control of very specific searches. All the examples I've given you so far are about knowledge of your domain in the abstract. Independent of the query the user gives me, I know that certain things are better than other things, and therefore I want that to factor into the score. QueryElevation Component is a way of saying, fuck the score. For this query, I know exactly what I want. All right? If you, for example, run an e-commerce site, you will most likely have a business user who storms into your desk one day and says, how come when people search for the iPhone, the Samsung Galaxy S is showing up in the search results? And you can go and say, well, let me look at the data. And you could say, oh, it's because in the review of the Samsung Galaxy S, the reviewer compared it to the iPhone 5 like 27 times. He just constantly is mentioning the iPhone 5 in the description of this product. And your business partner is going to say, I don't give a shit what the guy said. We're getting a ton of flack for this. It's blowing up on Reddit. Like, we need this gone. So that's where the QueryElevation component can come in. And you can say, when a user searches for iPhone, the very first frickin' result better be the document with the ID iPhone 5. The very second document better be the one with the iPhone 4S. After that, I don't care, but nowhere in that list should be the Samsung Galaxy S. He should be excluded from that search, flat out, gone. I don't want him there. This is definitely tedious to maintain. Don't get me wrong. This is not, you don't want to be doing this. You don't want to be going through your query logs and saying for every search every user has ever done, let's go and craft a handmade curated list. But it can be used as a nice fine-grained scalpel for saying, I have a very important person in my office breathing down my neck. How do I deal with this problem? All right? So domain knowledge is the big takeaway I want you to get here because it's the most generally applicable one. Almost anybody can apply that domain knowledge I was talking about. User analytics and personalization is a little more advanced, but it can be done. And I at least want you to think about it, especially when you're thinking about future projects. Like, a lot of people think of personalization as something that's really hard, or they think of user analytics as something where you need a lot of data. And it's true, to really do it right, you really need to put a lot of effort into it, but there are quick wins you can get. All right? To me, user analytics is anything where you go and you observe some information about your users or you measure some data about your users, and then you apply that to your own behavior, your own search behavior, your own application behavior. If you do it in the aggregate over your entire user base, see domain knowledge, because your users are part of your domain. You have said that on the whole, my users like mysteries more than they like cookbooks. Guess what? That's domain knowledge that mysteries are more popular than cookbooks. The second way you can use it, though, is you can take subsets of your users. You can either do it down to an individual user, and you can say user number 68493, this is what I know about him, and this is how I'm going to bias his search results based on what I know to give him better behavior. But you can also do it in a middle ground, a slightly more aggregate. Isabel, as I mentioned, the IDF and TF-IDF, she's a lovely person to talk to about Mahout and machine learning and how you could take all of your logs and all of your data and crunch them and learn interesting things like, for some reason, user Bob and user Sally have a lot in common. I don't know what they have in common because my machine algorithm didn't tell me what they have in common, but I know they're roughly the same. So now I can apply anything I learn about Sally to Bob, and I can influence his behavior. I'm not going to talk about that, but what I will tell you is even if you don't go talk to Isabel, and even if you don't run a 700-node Hadoop cluster where you do all sorts of data analytics, there's some really easy things you can do that a lot of people don't think about. First off, you can look at historic behavior. If you have registered users, you know some stuff about them. You can leverage that. Even if you don't have registered users, you can just set a really trivial HTTP cookie in a web application, which every time they do a search, every time they click a filter, every time they drill down into a category on your website, once they've clicked one link, you know a little bit about them. And you can record that information. You can record what keywords have they searched on in the past. What things did they sort on in the past? Did they ever say sort by price? Because if they did, now you know they care about the price. You don't know how much they care yet, but you know they care. If they sort by ratings, you know they care about product ratings. But also filters. If they ever drilled down, if they ever searched for laptops and then clicked on Apple as a manufacturer, you know that they care a little bit more about Apple laptops than they do about anybody else. What you do with that information, we'll talk about in a minute, but you know that now. Likewise, explicit or implicit demographics. If you have a registered user or if you've ever asked them what zip code do you live in so that I know how to mail you something, you can then go use that in various statistical tables to look up things like median income, typical number of children. You can learn a little bit about, statistically speaking, your user there. The last one, the really trivial one, you can look at their browser and their OS, and you may think, what the fuck do I know about that? How does that do me any good? There was a real estate site that put out an article that said just by looking at the user agent to determine were they coming from an Apple or an iOS device or anything else. That was all they did. They divided their users into 2 buckets. And depending on those buckets, when users searched for houses, they boosted things based on the median sales price of the geographic area for the people using iOS devices. They decided Apple users were more discerning and willing to pay more for houses. And they saw a huge uptick in their sales. Just by that one thing, that's all they did. No Hadoop cluster, no heavy analysis. All they did was say, are you a Mac user? You're probably willing to pay more. And then it worked. It actually worked for them. It got them tons of negative press when they admitted it, but it really worked for them. All right, so the personalization sledgehammers, similar to the domain knowledge sledgehammers, you can do things like saying, according to a cookie, the last time you did a search, you sorted by price. So this time, you're going to sort by price automatically. Fuck the score. Likewise, you can say, 5 minutes ago, you clicked on a category. You drilled down into Apple. So the next time you do a search, I'm going to assume you only want Apple. This is a slightly smaller sledgehammer than before, because in theory, these could be at least something the user might observe, and the user might personally understand it a little better, right? The user might say, that's weird, like why am I only seeing Apple products? Oh, I see, in the left nav, it shows me that I'm only seeing Apple products, and I did just click on Apple products 5 minutes ago, so that might make sense. But you can still do better than this, all right? You could personalize with the same functions we talked about before. You can say, whatever my user's current search input is, maybe I'm going to boost by the product of query scores from their previous search input. Whether you actually want to do this depends a lot on how much you know about your user base and their overall aggregate behavior. Also, you might want to take into account like how long ago was that search. If somebody was here like a week ago on your site and they searched for something and this is the first time they've come back, maybe not. But if they just did a search like 2 minutes ago, and they searched for Apple laptops and now they've come back and searched for something else, it might be related. It was really quick. So you don't want it to be a huge factor, but maybe you want to go ahead and say products that match their last query, like maybe those products should get slightly higher scores. Likewise, if they drilled down into a category recently, you can assume that then when they went to the search box, they were slightly more interested in that category. I've seen a lot of people do this not so much based on a cookie, but based on what page they came from. So if somebody does a search from the search box on their main homepage, they don't boost by anything. But if they drill down onto the site and say, like, show me new laptops, show me new Apple laptops, and then they do the search box, they still search the whole product catalog, but they boost the scores higher for the category you were in. And likewise, here's sort of an interesting, like, where this gets a little complicated. If their last sort they did was descending, like descending price, then you want to divide by it. If the last sort they did was ascending price, you kind of want to multiply it. It's a little tricky, but depending on your specifics, you can sort of apply that. These functions, though, you don't have to build them on the fly. You could also say I'm going to define some sort of generic rule about the fact that for every user, I'm going to determine a preference, a differentiator, and a confidence level. And I'm going to structure a function, and I'm going to reuse that same function for every user, but the inputs might change. So for Sam, his preference seems to be for laptops. The differentiator for him seems to be low price, so I'm going to divide by it. And he does this a lot, so I'm fairly confident. Sally, on the other hand, same function, because that's a constant for me. I've baked that into my configs. But her preference seems to be for Apple. Her differentiator seems to be user ratings. She's more discerning about what other people think. But I've only observed this a little bit from her. I'm not super confident of it. For my anonymous users, you just make the confidence 0. It doesn't matter what you put in here, right? There you're not biasing them at all because you don't know anything about them. That's all I really had to get through. I really want to give you one last sort of how far can you take this, right? How extreme can you get? Everything I've talked about so far is something I've actually done or seen people do. This is something I want somebody to come up to me at the next conference and say, I tried this, and it was awesome. Sweet spots. I mentioned before the sweet spot similarity. This is an example of what the function looks like for the length norm in sweet spot similarity. The idea that you can say, I've got a min value and a max value that should define a plateau. So we're looking at the red example here. My min value and my max value are 1,000 and 1,200. Okay? Anything in that range is the sweet spot. Those are all relatively equivalent. They all get a 1. If it's below that range, taper off. If it's above that range, taper off. The farther you get out of that range, the lower the score. Okay? This is how the sweet spot length norm works. So keep that in mind, but just think about how you could apply that function. This is the function expressed in terms of query parameters if you wanted to write it out. Now imagine that we apply this function to some field that the user recently clicked on to facet on, right? The user recently searched for laptops, and he clicked on the $1,000 to $1,200 price constraint. He narrowed his results. He chose to constrain the products he saw just to the ones being sold in that range. Then he went and did another search. Did he change his mind completely? You don't know. Did he completely change his task? 1 minute he was looking at laptops, now he's looking at some completely different product for, he's going to buy a gift for his kids. You don't know. But if you think he might be doing a search related to what he just did, you can boost. You don't want to hide products outside of that range completely because you're not 100% confident what he's doing. But if you have a little bit of confidence that what he's doing might relate to his most recent search, why not boost the products that you already know he's interested in? Why not boost the products in the specific range that you already know he expressed some level of, I like that, right? It doesn't have to be price. It could be anything. Any numeric field you have where you know this user was interested in this range of values, you can go promote and give higher scores to other documents in that same range. And it doesn't just have to be when they click on facets or when they click on filters. If a user comes to your site and clicks on a specific product, right? If they click on a specific laptop, and they spend a lot of time on that laptop. They read the whole review. Your analytics show that they actually kept clicking, and they clicked on every page of the review, and they clicked on the specs. Something about that laptop interested them. So what are the specs on that laptop? What is its CPU? What is its price? How much does it weigh? All of those are numeric values that you could then go build a function like this, or take this existing function and plug in values to, and say, well, he really liked this laptop. Its CPU was, I don't know what CPUs go for now, 1,000,000 gigahertz. So we're going to create a range of 999,000 gigahertz to 1,100,000 gigahertz. And let's boost other laptops in that same range. Or it has a 17-inch screen, so let's boost other laptops that have a 17-inch screen. This is something that gets a little hairy. The more functions you add like this, certainly the more complicated it gets. And the big caveat to all of this personalization is that it definitely decreases the sort of cacheability of your queries, right? It makes the queries a little more expensive, and it makes it much less likely that popular queries will be in the cache because you've modified them. But it is something that in theory, big air quotes, can really improve your user experience for your users. So I would love to see somebody try that at some point. In conclusion, TF-IDF is not magic. I mean, that TF-IDF is pretty cool, but TF-IDF, the algorithm, is not magic. It does not know your domain. It does not know anything about your users. It doesn't know your goals. It doesn't know your hopes, your dreams, your objectives. It doesn't know what business metrics you're going to be measured on this quarter. You know those things, and you can encode them and express them as a mathematical equation, and you can plug that in because you're the subject matter expert. You know all of this stuff. So think outside the box a little bit. Think about how you can augment that score, plug that in with functions. There's a lot of them. Don't assume the ones I showed you are all that exist. Go look at the Solr wiki on function queries. I think we have like 2 minutes left, so are there any questions? So the question was, the external file field, can you facet over that? The answer is no in the simple case. You can't do like field faceting, where you do facet.field equals to facet over the discrete values. You can't do trivial range faceting over them because they're not a real field. You can do facet queries on function ranges. So if you want to express discrete ranges of your own, right, and say, I know what I care about. I care about the values 100 to 200, 200 to 500, 500 and up. Those can be expressed as queries using the range function query parser, and you could then use the facet query option to facet over those. They can be used, they can be used anywhere you can use a function. And as of Solr 4.1, they can be sorted on natively. But anything you can do a function on, including function ranges, which can then be expressed in facet queries, you can use with those. OK, that's all the time I got. Thank you, everybody.